What's going on everyone? You're back with your boy Jono for another quick math lesson. Today we're going to learn about a new topic and it's one called surds, and this is just an introductory lesson to find out what they are and how we can operate with them incredibly easily. So a surd is just a special type of square root where the result or the answer is an irrational number or a decimal that goes on forever. Just as a recap, a square root undoes a squaring. Or it's like saying there's a number under the square root and we've got to find what number multiplies by itself to give that number. Just looking at a really quick example, if we've got a square that's got an area of 9 centimeters squared and I asked you to tell me what the side length was going to be, you could pretty easily tell me, oh, it's probably 3 centimeters. But the way that we would work that out is the square root of 9 is equal to 3 because 3 times 3 is equal to 9. This is the exact opposite of a squaring. 3 squared is equal to 9. The square root of 9 is equal to 3. So during our maths career so far, we've probably had a look at quite a few square roots. So the square root of 4 we know is equal to 2. 2 times 2 is 4. The square root of 9 is equal to 3. But what happens to those numbers in between 4 and 9? Like the square root of 5, the square root of 6, square root of 7, square root of 8. What do these actually mean? So the square root of 5, 6, 7, and 8 just sit in between 2 and 3. So they're on a kind of continuum. So if you just type in the square root of 5 into your calculator, it's going to equal something like 2.23 blah, blah, blah. And that decimal is going to go on forever. And then as we go a little bit higher, the square root of 8, that number's closer to 3, 2.82 blah, blah, blah. So as these numbers get bigger, they get closer to the square root of 4, 2, and the square root of 9, 3. So there's a whole continuum in between these numbers. The answers to these annoying square roots, the 5, 6, 7, and 8 here, are all irrational, and that means the decimal goes on forever. So it's not really helpful to write down that massive decimal because you could never stop. Sure, we could round them, but that's not going to be the most accurate answer that we could give. Just to make sure we're 100% on top of the language, a surd is always an irrational number. So the square root of 15 is 3.86 whatever, with a lot of decimal points afterwards. This is a surd because it's not a whole number answer. But the square root of 16 is equal to 4, 4 times 4, and this is a whole number. So the square root of 16 is not a surd, and it's really important to understand the difference between these two numbers. The reason that we use these surds is because they're so much more accurate than rounding to a decimal. So a surd is the exact full answer that you could give without any accuracy errors. We've actually probably come across these square roots in our mathematical career, especially during Pythagoras' theorem. So if I've got this triangle and I'm trying to find the hypotenuse, I've got 3 squared plus 5 squared is equal to c squared. So that means 9 plus 25 is equal to c squared. So c is equal to the square root of 34. The square root of 34 is this number's exact form. That's the best answer you could give. You could type this into your calculator and get 5.86 something, 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 but that's less accurate than the square root of 34. That is the best answer possible. So I know you're probably thinking, hey, this is pretty stupid. They're both pretty close. What's the difference? Who cares? They're both close numbers. But now with our ability to do 3D printing and laser welding without having to actually do it ourselves, putting numbers into the machine, it prefers us to use these exact forms because we can be incredibly accurate. Some of these laser cutters can go up to like the nanometer. So it's way better to put in an exact number because the machine will go 100% as accurate as it can. Better than doing some rounding and leaving yourself with a cut that doesn't exactly fit. The most important skill for this topic is knowing our square numbers. If there's nothing else that you remember for this whole lesson, knowing the square numbers is 100% the most important thing to take away. What I mean by this is 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. These numbers are so important because when you square root these numbers, they're going to give a whole number. So these are not surds. So we can see really quickly if I square root every single one of these, that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are our whole numbers that we will be trying to get to in later lessons. Making sure we know that these numbers give whole numbers and not surds is incredibly important. Thanks so much for watching this lesson, guys, and I'll see you later.